All right, honors algebra 2. So I know I had told you that we would do this question when I came back, but we're gonna do this question now. So when I left, we got the vertices of the region of optimal solutions were there. What is that? 2, 4, 3, 6, 5, 6, and 5, 1. So what we're going to do is the objective function is 4x plus 3y. You know, for every x you get 4, for every y you get 3, or it might be cost. For every x it costs 4, for every y it costs 3. We don't know if we want to minimize that or maximize that. So what we're going to do is we're going to plug 2 in for x and 4 in for y, 3 in for x, 6 in for y, plug 5 in for x, 6 in for y, plug 5 in for x, and 1 in for y. Where? So the objective function. So f of x comma y, I have that because I have x and y in my equation. So f of 2 comma 4, that one right there would be 4 times 2 plus 3 times 4. Plug 2 in for x, 3 in for y, and I get 20. And I do f of 3 comma 6. I plug 3 in for x, 6 in for y. Then I plug 5 in for x, 6 in for y. Then I plug 5 in for x and 1 in for y. And if I wanted to minimize this, the lowest value is 20. So maybe $20 is the smallest it'll cost, or 20,000 or 20 hours. And what minimizes that is 2 of x and 4 of whatever y is. Maximize this, it's 5 and 6, 5 of x and 6 of y. All right, so there you go. That's a pretty important question. And on a low level, this was in one of my last classes at SIU. All right, so we have then some more questions to talk about. And I wanted to go to, oh, that was page 7. What we just did was on page 7. Sorry about that. All right, this is awesome. This right here is page 12. You can always pause these when you need to. This is page 12, and I think we did this. We already did this one, yeah, by y, right? The y's were matching up perfectly, so we did this one already. The last day, you guys did a good job with that. Anyway, the answer was 5 for x, -1 for y, -3 for z. All right, let's talk about number 2 here. Solve the system. I'm going to say by z. The z's match up best. If I double the first equation, then the z's are either 2 or -2. So I double the first equation, which is what I did right there. 4x plus 2y minus 2z is equal to 10. There's my second equation. There's my third equation. All right. So I want to say by z, and I want to put equation 1 and 2 together. And I know I've done some of these in other videos, and I know you've watched them by now. That's something that just has to be improved, because we didn't do that in our last game plan. It was pretty disappointing. So, you know, if you're going to take college classes with me next year, or just go there, you've got to read emails and you have to watch notes videos. Some of your classes are going to be purely online, all right, given in this format. So we're going to start doing a better job, all right, because not doing so is no longer adorable. So we're going to add equation 1 and 2 together, and I know you've seen this before. So instead of writing like all of 1 out and all of 2 out, I'm simply going to write over on the left here that I'm adding equation 1 and 2 together. That's how I'm getting this next part. And if I add equation 1 and 2 together, I get 4x and x, and that's 5x. I get 2y and 4y, and that's 6y. And I get 10 and 16, that's 26. That's my new equation 5. Now I put 1 and 2 together. I have to involve equation 3 somehow. So I'm going to put 2 and 3 together because I have opposite z's. So I'm going to add equation 2 and 3 together. I have opposite z's, so I'm going to add. If I add equation 2 and 3 together, I get 16x plus 10y equals 28. Now I'm looking here, man, what do I want to eliminate? If I want to eliminate the x's, I have to multiply this by 5 and that by 16. No, thank you. If I want to multiply the y's, of 10 and 6, 30 is the lowest common denominator. So I'm going to multiply this equation by 3 and that equation by 5. So my new equation 4 and 5 is as follows. And the y's are the same sign. So same sign means subtraction. I'm going to subtract 5 from 4. And look at that, I get x as a -2, a nice answer. You're going to get nice answers unless we make a boo-boo. So I'm going to take that -2, I'm going to plug it into the original equation 4, 5 times x plus 6y. is equal to 26. Negative 10 plus 6y is 26. 6y is 36. Y 6. Y is 6 and x is a negative 2. I'm going to go back to equation 1. 2 times x plus y minus z is 5. Simplify. The opposite of z is 3, so z is a negative 3. That gives me a final answer of a negative 2, 6, negative 3. There you go. All right, that is page 12. And I knew we had to do that. That is page 12. Then we have to do as well page 13 was done. Page 13 was one that you did on your own. That was super easy. I mean, the last one was super easy. All right, so, whoa. This one has been on. This is page 14. This has been on in my notes document since my days at Mount Olive. So you guys can handle it well. What in the world are we going to say bye to? I think x makes the most sense. If I multiply this one by 6, multiply that one by 4, then all the x's are either 12 or negative 12. So that's what I did. I took equation 2, I multiplied it by 6, and I multiplied everything in equation 3 by 4. So pause that and do that if you need to. Here's what it turns out to be. You can always pause this if you need to. All right, so I'm going to put 1 and 2 together. I'm going to add them together, and then I'm going to put 1 and 3 together. I'm going to add them together. All right, and my z's are going to get crazy. Look at that. I have a negative 84z and a 36z. My goodness, be ready. So if I add 1 and 2 together, the x's cancel. I have 13y minus 79z equals a negative 38. That's equation 4. Wow. Then I'm going to take equation 1 and 3 and add them together. This plus this is a negative y. Well, that's nice. This plus this is 41z. Of course it is. Equals 16 plus a negative 48 is a negative 32. So the y's are much easier to get rid of unless you want to multiply that by 79 and that by 41. If I multiply this equation by 13, then I'll have a negative 13y with a positive 13y. That'll be great. So I multiply equation by 5 by 13 and I ran out of room. Okay, negative 13y plus 533z, goodness, equals a negative 416. The y's are opposite, so I put them together through addition. Add the z's together. Add that and that together. Look at that. Z's a negative 1. What a nice, pleasant answer for something that looked gruesome. I'm going to go back then to the original number 5, and I'm going to plug the negative 1 in for z. Add it. Negative y is equal to 9, so y is equal to a negative 9. Then here I'm going to go back to number 1 because x is positive. Then I have 12x plus 7 times y plus 5 times z is equal to 16. That's a negative 68. Add 68 to both sides. X is 7. That, despite the gruesome numbers we got a relatively pleasant answer. All right, fantastic. Let's go to the bottom here. Again, page 14. I'm going to say bye-bye to x. Now, you can make the case for bye-bye z as well. You can get rid of the z's if you double that one and double that one. So if you did that and got the answer of 415, you're correct. I said bye-bye x, and we wrote in pen, so we're rolling with that. Double the first equation, double the third equation. Here's what I got. And I'm going to put equation 1 and 3 together, and I'm going to put equation 2 and 3 together, both of them through addition. I don't want to subtract. So when I add equation 2 and 3 together, I get a negative 3y plus 3z is equal to 12. I could divide that all by 3 if I wanted to, but let's see what happens. Then I'm going to take equation 1 and 3 and add them together. Negative 4y plus 6z is equal to 26. That's equation 5. Well, I have a 6z and I have a 3z, so I'm going to double this equation here. I'm going to double that. Oh, that's not equation. You can't have two equation 5s. That's a new equation 4. The new equation 4 is all of this doubled. So I have a negative 6y plus 6z is equal to 24. And I'm going to subtract the two equations. Negative 4 minus negative 6 is 2. 26 minus 24 is 2. 2y equals 2. Y is 1. Y is 1. I'm going to plug, where am I going? Where am I going? I'm going to equation 4. I'm using equation 4 here now to find z. Negative 3 times y plus 3z is 12. Negative 3 plus 3z is 12. Add 3 to both sides. Z is 5. Z is 5. I'm going to go back to equation 1. It has positive x. X minus 3y plus 5 is equal to 6. X is equal to 4. 415. Again, you could say bye-bye z, and you get 415. If you do, then you're good. Okay, great. Let's keep going. We've got, nope, that was done. 16 was done. So in my estimation here, I think the only thing that you might have to finish out this game plan is this ACT. I don't think I did this ACT with you. I think I gave you the answers, but I don't believe I did it. All right, now it's important to practice these ACTs because it's you that's going to be doing them. This ACT score could win you a lot of money. Okay, so don't just simply get out the answers. That's one of the easiest things now to prep for, and so is the SAT with so many things online, Khan Academy. This is a test that we can practice for, and you can get a lot of scholarship dough for it. What's the least common denominator? 15, 12, and 8. So what I would do is I'd just look at these numbers. I'd 40 divided by 15, decimal. Nope. 120 divided by 15, that's 8. 120 divided by 12, that's 10. 120 divided by 8, that's 15. And that's the smallest of those numbers, so it has to be 120. That's what I would do. Okay, 8, this is coming from Algebra 1. 2 times 3 is 6, so that eliminates J and F. And what do? You add the exponents. That's 4x's times 5x's, that's 9x's. That's 1y times 8 of them, it's 9y. You add the exponents. That is a property of exponents that you learned in pre-algebra. And then in Algebra 1 again. It costs $8 for an adult ticket and $S for a student ticket. The difference between 12 adult and 15 student tickets is $36. It's the absolute value because a student dollar could only be like, it can be really close in price. So, it could only maybe differ by $1 sort of thing. It can be $3 for a student ticket, $4 for an adult ticket. So actually, if you did adult minus students, you'd have a negative number. All right, so that's why it's the absolute value. The total difference is 36. All right, 10. Also, that's the only one that has a difference. Okay, that's the addition. That's not. That's division. It's got to be C. If x is greater than 1, then which has the least value? So unless you can see, the square root's going to give you the smallest. I mean, the square root of 2x is already being doubled. That's got to be bigger than x. That's the square root of x, but then multiplied by a bigger number. And then that's got to be the biggest, so it's got to be f. But you can always let x be 3. Take the square root of 3, that's your number. If you double 3, you get 6. The square root of 6 is that. X times x, if x is 3, is the square root of 9, which is 3. If you plug in 3 here, 3 root 3 is 5.2, and 3 times 3 is 9. What's the smallest number? It's that one right there, which is the square root of x. So number 10 is technically still supposed to be a pretty easy question. So they're saying this equals that. So you do, let's just follow along here. So what is this, diamond this? Okay, so you take A and C and you multiply them together. A times C plus B times D. B times D over A times B minus C times D. I plug that in right there, and I get a -1. Not too bad, not too bad. Again, the ACT math goes from easier questions to hard. In the first 20, we shouldn't be too confused. In the figure below, ABC is 110, there you go. What else? BAC is 30. Add them up, subtract from 180, that's got to be 40. What is this angle? They are supplements. Do 180 minus 40. You get, I did like Right, that's how I got, that's the 140. You get 40 degrees right there. I'm sorry. And then this angle right here, yeah, 180 minus 40 is 140 degrees. This is an exterior angle. An exterior angle is always equal to the sum of the two remote interior angles, which is something you learn in geometry. So notice it's the sum of 110 and 30 as well, which is 140 degrees. The isosceles, you got a 45, 45, 90 triangle. Side, side, side root 2. AB is 10 feet. So if it's an isosceles triangle, this has to be 10. And then you could do 10 squared plus 10 squared. It's the hypotenuse squared. It's 100 plus 100. You take the square root of 200. Oh, man, what's the square root of 200? Well, it's not 5. It's not 10. It's 10 root 2 because we'll do this a lot. The square root of 200. What goes into 200? 102. And what's the square root of 110? That's why you get 10 root 2. So the answer is 10 root 2. If you type in your calculator, it might say like 14 point something. I'm assuming 14.14-ish. Just see which number is closest. 10 times that is 14.14-ish. So that's your answer. It's 10 root 2. Side, side, side root 2. 10, 10, 10 root 2. All right, many different ways to do that. In a bag of 400 jelly beans, 25% of them are red. What's the chance you pick something that is not red? A quarter of them are red, so 3/4 of them are not red. Can you believe? I mean, seriously, I think my 2 2/3-year-old daughter has a shot at that one. That 3/4, that was not difficult. All right, folks, so that concludes your chapter 3 game plan. Now, I might show you how you can scan that into me. If not, hold on to that. There might be a video. I got more videos to make, but I can catch up on them here. A video on how you can scan a document to me, taking photos with your phone, especially if an iPhone. It is super easy. If not, there are other ways. All right, this is Yak Math Videos signing out.